Good evening, everyone.
Good evening. How are you today?
Good evening.
I am well, thank you.
So let me start by showing you the what you have for this week. This is the busiest week. I haven't heard from the school yet about the date for the final exam, but the assignment this week, if you finish them, then the only thing will be left for you is the final exam. So this is
the homework's not on Alex yet. I'm not sure if you know that.
Yeah, I'm talking about the one in Alex, right?
Yeah,
they'll by midnight.
Okay.
Yeah. So this is what you have. Like I said, if after this week, the only thing that will be left for you is the final exam. So this is your busiest week. Some of you have started, especially the Excel assignments. Some of you have started it. So you have the reading material. The chapters, you don't have to read all of them. Just cover the areas we covered in the class. So don't go beyond that. But if you can, fine. But I will not ask you. I'm only going to ask you a question on what we covered in class. So if you get to that point, then you can stop. Maybe when you finish the class, you can explore. Statistics is a very interesting course. So chapter 6, 7, 8, and 10. Then the assignments. So homework 5, homework 6, and test 2, that will be by midnight. I would say check it again. If you are still awake at 2 a.m., it will be there. They will be there. Now, Excel assignment are already there. Project is there. Now projects, if you look at the project, you see that they consist of questions that we have covered in the class. Some of them we have not done yet in the class. So you can start early, cover those areas that we have done already in the class, and then by the end of this week, we'll cover the rest of them and finish it up. So that's why I made the project due on the 10th instead of the 9th. Then discussion. This will be our last discussion. Okay. Now let me show you how the project looks like. You can see the screen, can you?
Yes.
Let me show you how the project looks like. The project, of course, you can find it from the assignments section. And this is the project. Hold on, let me see. I got it here. Yep. Actually, the Excel assignment, they are part of the project. You're not going to do any more Excel assignment after this week. So this one's the 6 and 7. I'm not sure. I didn't include it. So hold on. It's only 4 and 5 that you do stop. Now this is the project right here. You click on it, and then it will open up. You will see this is the project question here. This is how you download it. It's in a Word document. So you download it and then see the questions. See, that's the questions. You can if you like, you can like this one, the histogram, for example, you can draw it on Excel and then copy it, remove this, then copy the one you draw in Excel and paste it here. You can do that. It's acceptable. So also, you already know how to calculate the mean. So in Excel, you can do them in Excel and type in your answers here. Not basically not. So all these things you will do using this data set for the project. That is the data set. What is it? I think this is where it is located. What is all my windows? Okay, I think it should be here. Give me 1 minute. I want to close this. So all these things you would do using this the data set for the project. Here is the data set right here. The same place you download the project question. So you click on it, and the data set is already in Excel. So you don't have to start typing it in Excel. It's already there for you. So you can just, open it, and then calculate. Calculate the standard deviation, then go and type it in. So when you submit the project, you can also upload the Excel. I want to see the Excel. If you did all your work in Excel and then copy them in the project, I want to see both of them. that's about it. Oh, there's one more thing. I forgot to open the Excel for this although we may not be needing it tonight. So let's begin.
Sir, before we begin, sir.
Yes.
I have a question on the Excel assignment, the assignment number 5. I just want to ask a question. I want to clarify something. When you gave us the example to type A2 for the X value, and you said we should repeat the procedure above for each data value in column A, are you saying when we put A3, when we want to get the standard deviation and the average, are we going to use A2 to A9, or we are just going to use A3 to A9?
Well, to get the standard deviation, you use the same all the numbers there. I can show you an example. You don't have to see if you are confused about the method I explained in the project. You can use this. Okay, give me 1 minute. Let me see if I can open. All the project, I made sure that the difficult part is just the data entry part. Okay. Now, so like I say, if you don't understand the steps in the way I described it there, you can use the method I'm about to show you now. Let's say that I have these numbers. Okay. I'm not seeing the question, so I don't know exactly what you're asking, but I want to show you alternative way you can do it.
But we can't see the screen you're explaining on.
You can't see it?
No.
Okay, I'm gonna so if you cannot do it that way, you can just do it this way. Okay. So assume that this is what you have. Type in your variance, whatever you want to calculate. Type in your standard deviation. So that's why you say repeat it, because you follow from the same place all the way down to get your variance. Then you follow this from the same place all the way down to get your standard deviation. So variance, to get the variance, all you have to do is to equal. Then type VAR. Now, because this is a sample, I'm going to use var.s. See, that's dot sample. You double click on it, it's there. You highlight it. Okay. Then close the highlighting, close the parentheses. Then press the enter key. It gives you the same thing. Now, to do the standard deviation, you do the same thing again, but this time around, you're going to type equals stdev dot s. See, dot s. So that's why you say repeat it from the same number, from here to here, and then close it, and that's give you the answer. So the only thing I want is that make sure if you do it this way and submit it, you are still good. You know when you are trying to explain something and the person is not there, you write so many things, like all those words, that too much explanation might get you confused. This is all I'm trying to say in that explanation. So if you follow this down and you submit this, I click on here, I see your answer, I see the work. Even if your answer is not correct, but I see that you did the work, I still give you some credit. Okay?
Okay.
So I guess we can start now. So oh, it's okay. Now let me share my screen. Where we stopped last time is normal distribution. We stopped at normal distribution as a probability distribution. Yep, this is where we stopped. You can see the screen, I believe. Hello.
Yes.
Okay. Good. Good. Now, it's a find the probability for each of these using the standard normal distribution. So find the probability of. I will do some examples so that to get you have a hang of it. Now, remember what I told you. Please, because I have seen this a lot of times, use the table that I provided for you. There's nothing wrong with using a different table. If you know how to use them, fine. But not each table have their own rules. If you use the rule that I'm showing you, this table have its own rule. If you use the rule for this table and apply it to the cumulative time, you get your answer wrong. So that's why I recommend use this and you'll be fine. Now, it says here to find the probabilities for each using the standard normal distribution. Let's start with the first one. Part A, we're looking for the probability of Z equals like that, my solution. Okay, 0 less than Z. This thing means find the probability between 0 and 1.96. Matter of fact, and let me change this to 1 point, and 1.96 is too common. 1.45. Okay, 45. Yeah, and do that. So between 0 and 1.45 equal. So to find this answer, first thing you do is to draw your chart. If you're using a hand, pencil and paper, it's much easier to draw the charts. So I'm gonna draw the charts. I must confess I'm not a good artist, but you know, I think you get the point though. So, and I have between 0 is at the middle, and 1.45, 1.45. So now I can put the x-axis, okay, between 0 and 1.45, and then put the center line that represents 0. Okay. Now 1.45 is right here. It can be anywhere on the right side, so long as it does not close the end. So it's between 0 and 1.45. So yeah, you gotta shed them. I wish I can shed only this side, but it wouldn't let me shed only that. So I can just use this to shed it. Okay. It takes all the time, but it's worth the time. If you follow the step I'm showing you for each of them have a different drawing, a different shading, and the solution to the question depends on the place that is shaded. So that means that if you shade the wrong place, you get the wrong answer. If you shade the right place, you get the right answer. And where do you get the answer after the shading? You get the answer by looking at the table. I also provided you with the procedure table that you can look at and follow the instruction from there. So between 0 and 1.45, then let us, so to find this area, remember I told you that half of this is 0.5 and half of this one is also 0.5. So if you're looking for only this portion from 0 to 0.4 here, all you need to do is to look at the table and get the area. So let's go to the table and look for 1.45. We go to the table of normal distribution. And I also told you to print this table. Is table 5, 1.45. See 1.4, you can see 1.4 right here. Now you have to go under 5. So at 1.45 is 0.4265. Let me write it down. 0.4265. That's 1 minute. 0.4265. And that gives us the answer right there. 0.4265. 4265. Or if you like, call it the A.
Excuse me, Professor. I don't get how you got the answer from the table.
Okay, give me 1 minute. 1.4, right? But you know the number we are looking for, right? Huh? Hello.
Yes, I do.
Okay. So now you go to the table. Here you can see the Z right there, right? Can you? Hello.
Hello.
Yes.
So you go to 1.4. Can you see 1.4?
Yes.
And then look at 5. Because you say 1.45. So the last number is on this side. The first two numbers is the Z, is the first part of the Z. The last digit is on this side. So 1.4, you go under 5. That gives you 0.4265 because it's under 5. Okay?
Okay,
So,
thank you.
Hello,
welcome.
Professor.
Mm-hmm.
Yeah, I have two tables here. You give us two different type of tables. How do we know the one we're supposed to use? Because I was actually looking at the other one. This one says binomial probability distribution, and this is the standard normal distribution.
See, look, each of the topic have a table. When we are doing binomial, use the table for binomial.
Okay.
Now we are doing normal distribution. So you're going to use a table for normal distribution, which is this one. Okay?
Okay.
That's how you know. Okay. So so the answer becomes 0.4 to 1 or you can call it 42.65%. So that's basically what it is. You draw it. Now remember, your answer depends on what part that is shaded. If you shade the wrong part, it might give you a different answer. Let me explain with you this example, part B. Part B says to find the probabilities for this P, Z less than 1.65. Okay, I'm going to move this down so we can be able to do this here. So B part said the solution is to find Z less than 1.25 equal. Yeah, now, and again, first thing is to do what? To draw. So you must be good at drawing. Draw the charts. Now I can put here 0 at the center. And 1.65 here. So that you can now add the x-axis. Okay. And then put the center line, which represents the 0 or the mean for the standard normal distribution. Now it says less than 1.65. 1.65 is positive, so it is here. It's a positive number. So it's less than that. So let's put the line that would represent 1.65, which is this line here. Okay. Now I say less than this number. That means everything on the left side represents less than 1.65. So you're gonna shade all the way to the back because those are the things that represent 1.65. Okay. You can see that while shading it, you don't cross the 1.65 line. Don't cross over it. Can go from it all the way to the back, but don't cross it, because if you cross it, it will make you to look at the wrong number at the table. See, I didn't cross the line. I just touched it. I didn't cross it. See, never cross it. Okay. Now, so we have this all the way to the back. Okay. All right. Last one. So, I mean, from here, from this 1.65 all the way to the back means less than that. For this, you know that half of this is 0.5. So you gotta put 0.5 first. Plus, now, let us find this part. Remember, half of this is 0.5. So we have the whole of the left side is shaded. That represents 0.5. And for this part of this, but it doesn't, everything here is not shaded. So to get only this part, you get it from the table. 1.65. Let's get it from the table. 1.6 under 5. You got 1.6 here. Then you gotta go under 5. So 1.6 under 5. Got 0.4394. 0.4394. Yeah.
Excuse me, Professor. Are you using the table 5?
The same table. Remember, I told you, if you are doing normal distribution, you have to use the table.
Because 1.6 under 5 in my own place, I'm getting 0.5 0.4505.
Yes,
Yeah.
Professor, you're on 1.5.
Oh, I was on 1.5. Okay. It's 1.6 under 5. You're right. Sorry about that.
Yeah, that's 0.4505.
4505.
Yeah.
4505. You're right. I went on the wrong Z value. 0.4505. So let me we go and put it, and that will give us the answer right away. 0.4505. When you add them, you can check this with your calculator. When you add them, you're gonna get 0.9505. Or if you like, you can call it 95.05%. Okay. Question?
Excuse me, Professor. Can I see the workings of the first one we did, the one from 1.45?
This one here?
Okay.
This one, you didn't add it because you didn't shed this part. You shaded only this, so you don't have to add anything, just get it from the table.
How
But
do
here-
we know? How do we know the one that we have to shed or the one that we don't have to shed? How do we differentiate?
Look at the symbol here. Say less than 1.65. This is
Yes.
1.65. Everything
But the
behind
first one too was less than.
no, it's not. It says is it less than? No, it's not less than. Say from here. Say look, 0. He give you two values. Z is
Okay.
at the middle. It may say from 0 to 1.45. See, from 0 to 1.45. Okay.
Okay, sir.
Here
Okay,
is less than.
Professor, I have a question. The second question.
Go ahead.
So how, I mean, does that mean the left side from the 0 is normally always 0.5?
Say it again.
Okay, like the solution for the PZ is less than 1.65.
Mhm.
You went straight to it's equals to 0.5. Where do you get the 0.5?
I remember when I introduced normal distribution curve, I said that one of the properties that half of this is 0.5. Halfway, this side is 0.5, this side is 0.5. So that the total area is 1. So that 0.5 curve, see, if you look at the whole of left side was shaded, which is the 0.5. On the right
thank
side.
you. I
Oh,
get
yeah.
that.
Good, good.
Yeah, I get it now. Okay. Thank you.
You're welcome. So now let's try one more example so you can now explore by yourself. Suppose we try part. Let's try this one because they're the same number but a different sign. After that, we try another one. See the same number, 1.65, but different symbol, so you can see the difference. This is let's say that we're looking for this probability Z solution. Okay. Z greater, this time is greater than, right? Again, you draw your the normal curve first from here. Okay. You guys, you know, if you see drawing with a free hand, you see that you know that it is much easier to draw it with a free hand. Never mind that mine is taking time because I'm drawing it with not with a free hand. So this time around, it's a 1.1, it's still 1.65. Yeah. Now you can put the x-axis. We have it from here all the way to this spot. Then, of course, put your center line, which is the mean. Present the mean for the data sets. And because it is a standard normal distribution, the mean is 0. Now it's a greater than. So let us put 1.65 first. Okay, 1.65 is right here, same place. But this time you say greater than. That means from here up. From this place up, we say greater than. So you like share it. So we share this. Okay. So by now you will notice that everything depends on what the symbol said and how the diagram looks like. So that will help you to figure out what to look and whether to add 0.5 or not, you know. Okay. Now, this last one. So when it is here, we call it the tail. Whenever it's at the tail, whether it is on the left tail or right tail, the same principle, you're gonna do the same thing. So whether it's at the left tail or right tail, this is what you're gonna do. This is what you probably call a tail. If it's at the here, it is still the tail. Left tail, right tail. Whenever it's at the tail, what you're gonna do is say, look, we are looking for only this portion. Remember the whole of this half is 0.5, but you're looking for only this portion. So what you're gonna do is do 0.5 minus the answer you find on the table for 1.65. So going to the table, we find 1.65, 1.6, you go under 5. We have it before as 0.4505. So you put it there. So, but this time you're subtracting 0.4505, which we can now get from the when we do with the calculator. So where is my calculator? It's over here. 0.5 minus 0.4505. Okay, 05 is 0.49, 0.0495. Yeah, 0.0495. Yeah, 0.0495. Or if you like, you can call it 4.95%. See, it's easy. It's not that bad. Am I right? Or wrong?
Correct.
Well, let me do one more on that section there. You can try the rest of them by yourself. So I'm gonna move this down. Yeah. Okay, let's see. We have, let's try this one. When one of them is negative, one is positive. Yeah. Let's try this. It's not enough room. So I'm gonna put it here. Solution. Okay, equal. So next thing is to draw your charts. Okay. You have this from here. Then you type in your numbers. Say from negative 0.45. Yeah. Okay. That's too far away. Okay. Negative 0.5. You're gonna move in. Negative 0. It's too far away. Okay, negative 0. 2.46. 0.
The 2 point or minus, okay, minus 2.46.
1.74. You can put your x at your y axis. Your x axis, I need to say. So you go from here. 10 minutes left. Let's see if we can use it to try another one. So you put this. Okay. Now, for this one, negative 2.46, you're going to put the line, which is right here. Then for 1.74, the line is right here. It says between the, when it is in this form, like here, like the very first one we did. See, between it means between these two numbers. That's why Z is lying between. So it's between two numbers. Here, same thing here. Z is between two numbers. So that means you're gonna shed between the two numbers. So you're gonna share this. While sharing, make sure you didn't cross the line for the two numbers. Okay. All right. Okay. Okay. All right. I think we have one more. Actually, two more. Last one. So between these two lines, that means you're gonna find this one, and add them together to get these two portions. So negative 2.46. You go to the table. Now, you don't see negative here, right? In the other table, there's negative one part of it. I don't use that table. That table is fine. Nothing is wrong with it. I'm just use this one because I like this one better. If you know how to use it, it's a different rule. You can use it, but I recommend that you use this one. So we're looking for negative 2.46. Let me write it down so I don't have to start thinking about negative 2.46, and then 1.74. So let's start with negative 2.46. So we go there, we don't see the negative side. But if you remember the properties of normal distribution, that the asymmetric, one side is smaller than the other side. So negative is just to tell you that it's on the left side, that's all. So that means for negative 2.46, just look under 2.46. So 2.4 under 6. 1, 2, 3, 4, 5, 6. And you can see from here, 6. See? So 2.4, okay, under 6. It's give you 0.4931. 0.4931. I wrote it down. So let me go and type it in. So we have 0.4931. 4931. Then plus, you look for this 1.74. So 1.7, you have 1.7 right here, and 1.7 right there. So 0, 1, is it 1.74? So 0, 1, 2, 3, 4. It's the 4 right there. Because this is the 4, you can see it at the top, 4. So it gives us 0.4591. 0.4591. So you add them together. Put it, write it down. 0.4591. So we'll add it together, which we can do using our calculator. Okay. 0.4931. 0.4931 plus 0.4591. 0.9522. 0.9522. Okay. 0.9522. 0.952. Or if you like, you can call it 95.22%. Questions? Hello, class. Any question for me?
I have a question, Professor. So the negative sign now automatically is no more there. You just have
It's
to know
here.
that because the negative is on the left side.
Yeah.
That's why it's there.
Yes, because it's just like your body. Half of your body, the other half is the see your hand. They are the same. If you look at the body,
Okay.
but this one is on the left side. So they use negative to show it's on the left side. That's all.
Okay.
So you are looking at
Thank
the absolute value of that number in that table. But if you're using the other table, it's a different scenario. That's why I use this one. Another question? You have
I
3
do.
minutes
What
left.
happened to the 0.5000?
Say it again.
What happened to the 0.5000?
You don't need it because you're only adding these two. Remember, it says between these two values.
Okay, okay.
Yeah. If it says like here, it says on the left, on the tail, the whole of this part is 0.5. But you are looking for only this part. It didn't say between the values, just say find this part. That's when, because you have the whole of this is 5.5. So you subtract this answer from 0.5 to get only this portion. But here, you want you to get the number, the value between these two numbers, which is from here. Yeah.
The first one where you have the 0.05505. No, go back down. You were just showing
This
it to the only, yes, that one. Where did you get the 0.4501?
This, you mean which one? 4505 or it's 45 from the table. From the table, you look for this on the table.
Okay, and but the 0.500 is the 0.
You mean this one here?
Yeah, where did you get that number from?
The half of this is 0.5.
Okay,
and it's shaded. Then this one is the one that you get from the table.
got it.
But the half of this is shaded. That's 0.5. That's where the 0.5 came from. Another question? All right. Now we'll come back because with the time that's very soon. We'll come back. We start from doing. Well, what we do when we come back is the opposite. Where in this case they will give you the probability, and they'll ask you.
Please, Professor, can I see the one we just finished now? Thank you.
Yes, sure. So the one we finished, the one we did now is where they will give you the Z, and they will ask you to find the probability. Now, what we do when we come back is they'll give us the probability and ask us to find the Z. So we will be doing the opposite. So instead of looking instead of looking on the left side of the table, we look inside the table to locate our Z. So that will be our next where we will begin when we come back. Okay. So it's just a minute. So I'm gonna instead of letting it to time us out, I'm gonna close it, log back in 10 minutes time like we normally do. Okay. I will see you back then, right?
Hi, Professor. Have you seen my message?
Message. No, I have not checked my email today.
No, direct chat right now, but I can send it on email. All right.
What's your name?
Lizzie.
Lizzie. Okay, I will check it when we come back. Okay, before we come back. Yeah. All right.